most of you may or may not know my story. 12 years ago, I was a big dude, really big dude. And it was one of the things that kind of really bothered me. And the thing is, I would tell you, from failures, you get your successes. And no matter what your issue is today, there's going to be something in this talk that is going to allow you to improve your own situation. And for me, it was a crazy story that many of you may have heard in the podcast. It's tied to this book. And I'm not going to get too deep into the book, but it's an old one. But here's the key. It was a guy named Julian Battle, who's a famous attorney in New York City. Remember, this is a fable. It's a bullshit story. It's not for true, okay? But it turns out he had a heart attack in the middle of the courtroom, and he was an asshole. That means low dopamine. So that's the reason why I started out with the low dopamine story. Well, he has a heart attack. He decides to sell all his earthly things, go back in. He went to the Himalaya mountains, came back, realized that there's 25,000 sunrises in a life. He was tan. He lost 100 pounds. And he was a nice guy now, and people couldn't figure it out. So the person that sent me this book was trying to give me a different message. And that message for this talk is not important. But what is important is, what did I take away from this book? Those things right there. Those were the key things that I didn't know. I didn't know these things were possible. Then I started thinking about the book after some of the papers that I'd started reading. I said, is this possible that this could happen in real life? And that was my picture around 2005. And I was a low dopamine neurosurgeon at that time. Some people may still consider me that way, but I think I'm a little bit better than I am today than I was then. But I want you to look at the title of that. I guarantee very few people in this room believe what's up there. Does obesity begin in the eye? I'm going to tell you, when I'm done with you, you're going to see a different perspective than you've ever seen before. Because I'm going to tell you the answer is yes. And how I got pretty famous on the internet is by writing something called a leptin prescription. When you go read it, you'll never see the word light in it. It just gives you 6 steps to do, and you'll find out why those 6 steps are important. But what did I do when I read the book? Immediately, I realized the guy went to the Himalaya mountains. What's really interesting about the Himalaya mountains is, you see India's right here. The equator runs right through here. Noticed that the equator bisects that country. The other thing that I knew about the Himalaya mountains, they're really high up, like 25 to 30,000 feet. And one of the things that I realized immediately is that would change the light frequency of what that person would get. And it turns out, for every 1,000 feet you go up, you get more UV light. And then I remembered in the book, he said, yeah, he was tan. So that meant he had to have a lot more UVA light, because UVA light tans. I did learn something in medical school from dermatologists. But the other key thing that I started to notice is, I remember in medical school learning about how haplotypes in mitochondria vary by geography and also by latitude. So this is the key. This is where the cradle of life is, right here. Why is this important for everybody in the room to understand? Because people that live in the East African Rift Zone, the original humans, they have an L0 haplotype. What does that mean? That means they do not uncouple their mitochondria. Why is that? They need all their energy to run away from lions, okay? People that live up here, which is most of us in the room, why? Because we come from Northern European haplotypes, we uncouple our mitochondria. What does that mean? That means we don't use food electrons to make energy, to make ATP. We use it to make heat. Why? Because there's no lions up here. You don't have to worry about lions. You have to worry about freezing your ass off, okay? So you release heat from your mitochondria, and that does something specific to water that's sitting around your mitochondria. And what is that? It's something that's very counterintuitive. Warm shrinks water. Cold expands it. Well, why is that important to a mitochondriac? Well, it goes back to this story right here. And if you look, most of us have these haplotypes right up here. Well, when you take a mitochondria and shrink it down, that brings the respiratory proteins closer together. What do we know in quantum physics? Anytime you have an energy transfer, when electrons move across a redox couple, the closer they are together, the more energy efficient they are. Isn't that interesting? I started putting these things together. I said, somehow that must be important. Then I started to read papers that every 1 angstrom, the distance between respiratory proteins drops off the energy it makes by a factor of 10. So what did I start to realize? Was being a fat ass really tied to energy excess, or is it maybe tied to energy loss back to the environment? Got me thinking, and I wasn't sure, but this paper came from the #1 mitochondrial researcher in the world. If you don't know his name, this is a name you want to write down, Dr. Doug Wallace. And he just won the Franklin Award. That's usually something they give to somebody before they win a Nobel. He's going to win a Nobel Prize. He's the guy that found out that mitochondria are inherited from your mother only. He's also the one that linked all diseases, and this is going to shock you, because I know most people don't know this. You have 2 genomes inside every cell. You have your nuclear genome and you have your mitochondrial. Medicine focuses in on the genetic one. I don't. I focus in on the mitochondrial one. The reason for that, it makes all the energy in your body. And guess what we now know from the science of epigenetics? Energy turns on and off the genome. That's the only thing that does it. So we come to a point, how do we make energy proximal to a mitochondria in our body? Where does the process first start? Well, this is when I started to look at sunlight. And there's an interesting thing here. What your eyes can see is 380 to 780, okay? Just for those of you who don't know, this is UV light, UVA, and that's red light. But here's the funny thing. The spectrum of the sun goes from, this is actually incorrect, this is Dr. Wunsch's slide, but it's 250 all the way up to 3,000. So it raised a question, why are we not seeing these? And not only that, why is the retina, because most of you may not know this, we as humans are blind to UV light and to infrared light. We can't see it. But why is it there, and why doesn't our eye look at it? And I thought that was very peculiar. Then I started to learn about things in quantum mechanics. And the reason that that occurs is something called the quantum Zeno effect. And I'm not going to tell you what it is. I'm just going to tell you that when you observe a frequency, it changes the reality you get. And it turns out that all the key signaling in your eye works on the frequencies you can't see. And it's done that way by design. So, this question made me realize that there is an issue in the eye. We have an eye camera. Almost everybody in this room would not argue that your eye is predominantly something we use to see, as we're doing right now. But there's this other thing that I learned about in neurosurgery called the clock. It's called the supracosmatic nucleus. Most of you probably heard it. It's the main circadian oscillator. And I started to wonder, is there a difference based in these frequencies between these 2 systems in the eye, and how do they somehow link? So I went further. In 1879, everything changed. This is when we had the first incandescent bulb. I challenge anybody in this room to go back and find me any papers where there's any chronic diseases present. In fact, Doug Wallace has publicly said 85 to 90% of human diseases are related to mitochondrial origins. Okay? Chronic diseases began right around the turn of the century. For those of you who don't believe it, I think I told you this last year. In 1900, colon cancer was the 37th leading cause of death in the United States. Today, it's number 2. So if you believe in Darwin's paradigm, explain to me how in 5 generations we went from 37 to 2. It's impossible. But guess what makes it possible? When you understand the energetics from a mitochondria. And guess what? That's what Wallace has been teaching people, and nobody is listening in my profession. Okay? And that includes the PhD researchers, because they're the ones that teach us in medical school. But Wallace has been banging this drum for a long time. So the evolution of light doesn't equal the evolution built into your cells. Let's take it further. You saw this picture from Ruben. 4.6 billion years. 1980s, 1879, here. But this is the key thing I want to show you. What's the key in this picture? Red balances blue. Don't forget that. I'm going to make sure you have that burned into your retina when I get done with you. Now, if Dave wants to invite me back, we'll talk about the skin next year. This is not a talk about skin, okay? But it's important. But this year is all about the eye.